Hello, my name is Dan Gerlowski. I'm the professor for managerial economics, Econ 305, here at the University of Baltimore. I wanted to make a short video presentation for you about the mathematics and graphing of changes in demand and supply. I know we're working on demand and supply in our coursework, and some of the technical details I think people might need a little bit of a refresher on. I wanted to point out that this video should not replace the hours of work you're going to put in independently. Instead, this video should enhance what you do independently. My goal is to give you a background and a format to work in that you can apply to similar types of problems as we go forward. So having said that, I wanted to talk about the example for a minute. Our example is going to be a hypothetical depiction of the supply and demand for Coca-Cola in Baltimore. So what is our setting? Well, our setting is Coca-Cola is bought and sold in Baltimore, and we want to find a demand and a supply for Coca-Cola so that we can predict the equilibrium price. Now, the demand for Coca-Cola is going to be assumed to be dependent upon the price of Coca-Cola, which we've called PC, the level of consumer income, which we've called Y, and the price of Pepsi, which we've called PP. The exact form of our demand function for Coca-Cola is shown in the box at the bottom of the slide. The quantity demanded of Coke is equal to 7890 plus 0.76 times Y minus 115 times the price of Pepsi minus 2,500 times the price of Coke. Now there's a lot of terms in there. There's income, there's the price of Pepsi, and there's the price of Coke. All of those things impact the demand function for Coca-Cola. What are we going to do? Well, we're going to specify a supply function for Coca-Cola, which will depend upon many things as well. And we're going to look at an equilibrium that's produced for the supply and demand, where we assume values for consumer income, the price of Pepsi, and for the supply shifting variables. So that's our goal. Our goal is to look at a supply and demand system and to find the equilibrium. In a follow-up video, we will look at changes to the equilibrium that we just found. So we'll say this is our equilibrium now. In another video, the next video available to you, we'll change something like the level of consumer income, or we'll change some factor that in fact impacts supply. And we'll say, okay, this is how the equilibrium changed. So I hope you pay attention, particular to the mechanics of what we do. The algebra, the math. That's the part that most people get hung up on. The supply of Coca-Cola. The supply of Coca-Cola, as written for us, is going to depend upon the price of Coca-Cola, and increases in the price are going to bring about a bigger quantity supplied to the market. That's a typical expression of the law of supply. It's also going to depend upon the price of a key ingredient for Coca-Cola. Sugar is a very important ingredient to make Coca-Cola. Every can of Coke has sugar in it, and it would stand the reason that the price of sugar is going to impact the supply of Coca-Cola in the market. So if we look in our supply function in the box at the bottom of the screen, we say the quantity supplied of Coca-Cola is equal to 1,730 minus 4.3 times the price of sugar plus 3,000 times the price of Coke. What we need to do moving forward, just like we will do with demand, is we will specify a value for the non-price determinants of supply. Here we'll specify a value for the price of sugar. And then we'll solve for an equilibrium. At this point, we have a demand function and a supply function specified. We want to look now at what are the shifters of the supply and the demand function. We'll start with the demand function and say, how do we deal with these shifters? What are the shifters again? The shifters are things other than price that impact the quantity demanded. And in our quantity demanded equation, in the top box on the screen, we see that we have consumer incomes and we have the price of Pepsi. So we need to fix those values, not that they're broken, but we need to hold them constant and hence fix them in that sense. So what we're looking to do is say, okay, our measure of level of income is going to be $30,000. That's roughly a per capita income measure, and for Baltimore City it might be a little low or a little high depending upon who's keeping the data, but it's about right. For the price of Pepsi, we're going to assume the price of Pepsi is $6. So how do we deal with those shifting or those non-price determinants of demand? Well, we fix their values at $30,000 and $6 respectively, and we put them into the equation for Y and for PP. That's done in the second box on the screen. In the third box, you see the result. There's our demand function. The quantity demanded is equal to 30,000 minus 2,500 times the price of Coke. You know, that's a demand function. It's in simple form. It's just quantity and price. Keep in mind that within that demand function, you have a value specified for income and a value specified for the price of Pepsi. Our supply function, we have sort of the same thing to do here. What is the shifting variable in the supply function? The shifting variable in the supply function is the price of sugar. So we need to fix that value or make it constant, and it's sugar per ton. The future delivery contract price for sugar per ton is about $1,100. So we'll put $1,100 in there for the price of sugar, and we'll substitute that in directly for PS. In the second box you can see the substitution, and that leads to our supply function is the quantity supplied is negative 3,000 plus 3,000 times the price of Coke. So at this point we have a demand function and a supply function only relating quantity and price directly. The shifting variables or the non-price determinants of supply and demand, consumer income, the price of Pepsi, and the price of sugar are fixed. If they change, the equations will change. But for now, we'll say they're fixed. How do we go about solving that supply and demand model? Well, we need to understand that in solving two equations and two unknowns, there are many, many ways to proceed. You can use matrix algebra, you can use substitution, you can do algebraic manipulation. There are many other ways. What I'm going to use is an algebraic manipulation, and this form will always work for solving demand and supply functions if you follow along in these types of steps. So our first step is to say, what does it look like when supply equals demand? Well, the left-hand box on top shows the supply function. The right-hand box on top shows the demand function. If we set them equal, well, then we get that expression in the big lower box where we show the demand equation is equal to the supply equation. Now we need to solve it. So if we move on to solving it, what exactly do we do? Well, what we're going to do is we're going to get all the constant terms, those that don't involve PC or the price of Coca-Cola, on the left-hand side. To do that, we add 3,000 to each side of the equation. So if you look at the right-hand side, we had negative 3,000 plus 3,000. That goes away. Negative something plus positive that same thing equals 0. And on the left-hand side, we add 3,000 and we go from 30,000 to 33,000. Now we're still left with a PC term on the left-hand side. So our next step is to collect all of the terms involving price on the right-hand side. How do we do that? We have to add 2,500 PC to each side of the equation. And if we do that, we get the lowest box on this slide. 33,000 is equal to 5,500 times the price of Coca-Cola. So there we have, we're almost done solving the price. What do we need to do? Well, what we need to do is to get rid of the 5,500 in front of PC. So what we will do is we will divide both sides of the equation by 5,500. And if you divide 33,000 by 5,500, you get a price of 6. So we know the equilibrium price in this market, given our assumed values for consumer income, for the price of sugar, and the price of Pepsi. How many units are traded? Well, again, you can substitute the price back into the supply and the demand equation, and if you do them both, you've also checked your work. So we see that the quantity supplied, if we put $6 as the price in there, we get 15,000 units supplied. The quantity demanded, if you put a price of $6 in there, you get 15,000. And I'm sorry, there's another technical glitch, but that's okay, we're almost done. We know the quantity, we know the price. It might be interesting as well to graph those equations. And I went into Excel and I graphed those two equations. The demand function is reddish in color and the supply function is greenish in color. Now just to briefly recap what we did. We had a demand function and a supply function with things other than price in them. So we had consumer income, the price of Pepsi, and the price of sugar is in that equilibrium that we just found. What are we going to do next? We are going to change one of those three things or two of those three things and trace the changes through supply and demand and see how the equilibrium changes. We all know, for example, that for most goods, as income increases, demand increases and the price of the good increases and the quantity demanded and supplied of the good increases. We need to make sure that we can show that mathematically. Similarly, we could also shift supply. We could reduce supply. We know that when supply is reduced, the price goes up and the quantity falls. We need to be sure that we can track that through mathematically. And we will do that in the second video for Chapter 2.